The Heritage Council is an independent statutory body that reviews and decides what gets included in the Victorian Heritage Register. We celebrate the state's diverse cultural heritage and provide advice on its protection. The Heritage Council of Victoria has been a major sponsor of the Australian Heritage Festival in Victoria for the past few years. We are delighted that the festival sees thousands of Victorians experiencing heritage firsthand during the months of April and May, including today here at the glorious Ripponlea Estate. Climate change is changing the shape of Victoria, including impacting our cultural heritage. Over the past couple of years, both the Heritage Council of Victoria and the National Trust have developed climate change action plans in relation to the management of significant heritage places and sites. And as you can imagine, that would be really important for a site like Ripponlea with such incredible grounds. Protecting heritage is also a smart and sustainable way to reduce our environmental impact. As an example, adapting, restoring and repurposing existing heritage places often uses fewer resources than new construction. And I'm very excited to be here today with you all to discuss this topic further with our expert panel. I'll be guiding the conversation over the next hour, and after about 50 minutes of discussion, we'll open the floor to take a few questions, so keep that in mind as we go. Our panellists will all give a short presentation, each to kick off the discussion. And today on our panel, we've got Samantha Westbrook. Sam is the Executive Manager of Conservation Advocacy at the National Trust. She joined the Trust in her capacity as a conservation architect in 2014 and has worked in the executive team since 2016. Samantha is a registered architect with over 25 years' experience of working in the heritage industry, with involvement in all aspects of professional heritage architecture, including work in state and local government as well as private practice. Thanks, Sam. And at the end of our panel line here, we've got Tina Tam. Tina is an architect and certified passive house designer. She works on the adaptive reuse, refurbishment and extension of buildings. Sorry, I forgot to mention, Tina works with Level 10 architects. Refurbishment and extension of buildings, particularly heritage buildings. Many of her projects are award-winning and significant, such as Melbourne's Regent Theatre and the Old Quad redevelopment at Melbourne University. As a designer, she is interested in the translation of heritage ideas into buildable solutions, coordinating all elements of the construction process for best outcomes. Much of her work involves investigating existing structures, and she looks for design responses that balance the modifications needed for new uses with respect for a building's heritage significance, whatever the size of the project. And in the middle, we've got Peter Elliott, Adjunct Professor of Practice, Faculty of Design and Architecture, Monash University, from Peter Elliott Design. Peter is a Melbourne-based architect and recipient of the 2017 Gold Medal from the Australian Institute of Architects. He is currently an Adjunct Professor of Practice at the Faculty of Art, Design and Architecture at Monash University. In 2015, he was awarded an Honorary Doctor of Architecture by the University of Melbourne. He has a special interest in the design of public realm and has lectured and written extensively on contemporary architecture and urban design. He has authored 2 books, Episodic Urbanism in 2015 and an unfinished masterpiece in 2022. The work of his practice has won more than 85 national and state architectural and industry awards. This includes an Order of Australia in 1987 for services to architecture in public housing, an RAIA Victorian Architecture Medals for the Carlton Baths and Community Centre in 1991, and the Parliament of Victoria Members Annex in 2019. So as you can see, we've got a huge wealth of knowledge on the panel with us today, and really excited to share their presentations with you. Sam, do you want to start with your presentation?
Certainly, and I'm just going to stand up so I can actually see the slides that I'm presenting. And step down and stand up. So the National Trust in Victoria is the state's leading independent heritage organisation. Amongst other things, we support communities right across Victoria to protect and care for our heritage, including support for custodians of heritage. One of our key advocacy focus areas is demonstrating that heritage plays a significant role in combating climate change through retention of our natural and built-in heritage and through taking a thoughtful approach to change. The National Trust, as Ruth said, has a climate action plan written in 2021, and our second updated plan is soon to be released. So watch this space, that's going to be very exciting. Learnings from our first one. I'm going to briefly talk through the reasons behind heritage playing a critical role in combating climate change and what we can do to ensure it maintains this role. When we think of our historic buildings, we often think of them as vulnerable to climate change impacts. However, when we understand the sustainable materials and methodologies used in their construction, we discover that they're actually more resilient to climate change than many of our newer buildings. In addition, retaining and caring for these buildings further contributes to combating climate change, allowing these well-constructed buildings that use quality materials, or not allowing these quality buildings to fall into disrepair or be demolished, which is just devastating for our climate. As the saying goes, the greenest building is the one that is already built. So what are the materials and construction types that make heritage buildings more resilient? As a general rule, heritage buildings are often constructed from local natural materials and use better quality and more durable materials with more attention to detail in their construction. Some examples of this include timber species used in early buildings were dependent on location with utilisation of trees close at hand. These included ironbark, mountain ash and Tasmanian oak. These timbers could be harvested in larger sizes than available today, were milled on site or close by, and were often more durable. So they had a much lower carbon footprint. A piece of sound, aged timber will by far outlast its likely replacements these days. Materials such as stone and sand for mortars were also sought from nearby quarries. For example, the bluestone used to construct Pentridge and bridges in the Merrybeck area were quarried at what is now Coburg Lake. Oops. And as another example, linseed oil made from locally grown flax seeds was used to finish and preserve timber. And unlike modern paints that sit on the surface and peel off, it soaks into the timber, maintaining its moisture and preventing rot. Even early corrugated iron was thicker and more durable than the modern equivalents. Passive climatic features are present in many heritage places. They include things such as verandas, light-coloured pitched roofs, wide eaves, thick walls, and proportionally large established gardens that provide shade, insulation, wildlife habitat, and carbon dioxide absorption capacity. Features such as eaves, which extend beyond the walls and windows, block direct sunlight, preventing heat gain in summer. This passive cooling effect minimises the need for air conditioning, leading to lower energy bills and improved comfort. Additionally, eaves protect the exterior from moisture damage, preventing leaks and extending the lifespan of windows and doors. And that's Mills Cottage on the left, which you can see the shadows provided by those lovely wide eaves. Verandas also offer significant climate control benefits. Verandas are often features of our early buildings, primarily by providing shade and reducing resilience on artificial cooling systems. This leads to lower energy bills, increased comfort, and a more sustainable lifestyle. How can I talk about climate change and heritage buildings without talking about the wonderful lime? The sustainable benefits of lime used in heritage buildings is worthy of its own slide. Most traditional buildings pre-1920s were built using lime rather than cement. Lime was used in mortar for masonry buildings and internal and external finishes, such as lime washes, internal plaster, and external render or stucco. Lime is considered a more sustainable building material than cement for many reasons. It has lower energy requirements as it's produced at a lower heat than cement. This also means it releases fewer carbon dioxide emissions, contributing to the reduction of greenhouse gas emissions. Lime can absorb CO2, carbon dioxide, from the atmosphere during its curing process, further reducing its carbon footprint. Lime can withstand structural movement and weather conditions without significant cracking. This reduces the need for frequent repairs and replacements, further contributing to its sustainability. Lime-based materials can also be easily recycled and repurposed, reducing waste generation. They are also biodegradable, meaning they can be safely returned to the environment at the end of their life cycle. What a wonderful material lime is. Modern buildings tend to rely on an impervious outer layer or a system of barriers to prevent moisture penetrating the walls, whereas buildings constructed before the mid-19th century generally rely on allowing the moisture, which has been absorbed by the fabric, the building fabric, to evaporate from the surface, referring to it as letting the building breathe. The porous nature of traditional mortars that use lime and sand permits evaporation of moisture from within the wall. As the mortars are usually more permeable than the materials they bond, walls are often dependent upon the evaporation of moisture from the joints to remain acceptably dry. The use of lime to finish buildings internally and externally with lime wash, lime render or plaster, which could be coloured with natural pigments, was again a porous material that allowed the walls to breathe. Lime mortars were designed to be more permeable than the bricks, so that moisture can evaporate out through the mortar, thus maintaining the integrity of the bricks. And this is an example of Como where we've actually removed the paint. And while the mortar had disintegrated underneath the paint, it was easy to remortar the bricks, and they've remained in good condition. Another important aspect of heritage buildings is their repairability. The repairability of heritage buildings, because of the features I've already discussed, makes them more resilient to climate change. The quality and more durable materials, as well as the skilled craftsmanship used on things such as early sash windows, enables a greater ability for sections to be repaired without replacement of larger sections or the whole window. The same goes for weatherboards. This also applies to other timber detailing and framing. Similarly, mortar joints can be easily raked out and repointed rather than requiring the more energy-intensive replacement or reconstruction of whole sections of wall. So there's two examples of that, and there's a timber repair on the roof of Labassa. That window, which you can see on the right, it's been completely repaired and retained the early details of it. And then that's some repointing going on at Como. So maintenance, very important for retaining the integrity of our heritage buildings and allowing them to combat climate change. Regular ongoing maintenance is critical to retaining the sustainability of all buildings, not just heritage buildings. Regular maintenance and a conservation approach to repairs reduces the resources required to address greater building deterioration issues in the future, if buildings are maintained in good order and issues identified through regular monitoring. Making sure we understand our buildings and enabling them to perform as best they can is key. For example, the simple upkeep of putty and paint on traditional timber windows can greatly improve their thermal performance and help us reduce energy consumption before outlying on measures such as secondary glazing or replacement of timbers. So in the middle there you see a little bit of a workshop happening at Como with our wonderful glass artist and restorer, Bruce Hutton, giving us all a lesson on how to reputty a window. And that's just so important. And then you can see on the right what happens if you don't maintain your timber work on your windows and the putty. And so that window is just going to completely deteriorate and probably need replacing. But it's probably got great timbers and it could have lasted for another 50 odd years. Basic building maintenance is firstly about making sure water is moved away or off a building and into site drainage. Checking gutters, rain heads, downpipes and ground drainage all aid this. So we've got a gutter vac at the National Trust, and so that's on the left, so you can get up and you don't have to use the ladders to get up and clean our gutters. So that was an amazing purchase for the Trust. We have our maintenance team regularly going around all of our properties and clearing out the gutters on a regular basis. And seasonal During the autumn time is they up the maintenance of gutters and the clearing of gutters because of the leaves from the trees. When we make change to heritage buildings or restore them, we need to make sure that we're not reversing these inherent building elements that make them more resilient by covering over these features or deeming them redundant. For example, evaporation prevents solid walls from becoming continuously damp, but this crucial function is compromised by the use of impermeable materials in repairs, such as damp-proof membranes, cement renders and mortars, or synthetic paints. I've got Como there as an example before we remove the paint, so the outbuildings at Como, which we've removed and repointed the brickwork, so now the buildings can breathe. And then on the right here we've got a property in Chiltern where cement-rich render has been put on the exterior of the building and there's been cement-rich repairs. And you can see the deterioration of the bricks is because of those cement-rich repairs and the inability for the brickwork to breathe. In addition, use of new incompatible materials on heritage buildings can be less reversible or repairable. For example, cement-rich mortars and renders causing issues can't be removed so easily without causing damage to other parts of buildings. So yes, on the left, they've got paint and cement-rich render. If we take off that cement-rich render, it's pretty much going to destroy those bricks. So yeah, it's just doing so much damage to our buildings. And finally, we need to support tradespeople who have these traditional skills and can work with traditional materials such as lime and can undertake carpentry repairs to retain as much as possible of the durable early timbers and craftsmanship of early features. The skills required to undertake repairs rather than only knowing how to replace is crucial to retaining the sustainability of our existing buildings. Thank you.
Thanks, Sam. Thanks, Sam. That was incredibly detailed and very interesting. Lots of questions. No, I think it was really fascinating, and it's really important to note those ways in which the maintenance and repair of a traditional building really fits into that repair and reuse kind of movement, if you want to call it that. Now Peter's going to present.
Good morning all. Just a little bit of difference here. I think the idea of climate change is a very big subject, and I just want to touch on a few lessons learned and some ambitions in this area. I might put my glasses on as well. So I think one of the big impacts of global climate change we're well aware of, and you can just see even from those couple of slides that this is Australia, even just like the last few months. Massive floods, droughts, wildfires, heat waves, rising sea levels, melting glaciers, warming oceans, among other things. So it's a big issue facing the planet. So I started my architecture course in the late 1960s, believe it or not, and climate change is not a new subject. It's become just more urgent and understood. From the early 1960s, there was a worldwide environmental movement based on sort of self-help practical solutions. It was much more hands-on, don't know if you remember, sort of almost like the green approach to the world. So things like sustainable living, resource depletion, renewable energy, self-sufficiency, alternative technologies, solar and wind energy, and natural ventilation, and the sort of traditions of building that Sam laid out. So I remember all these catalogues, and as young architects we learnt kind of what you would call traditional building before things got changed and more sophisticated. It's slow. That's it. I think the next thing that I found really interesting, just looking back a little bit, was in the 1980s and 70s actually. There was a large community awakening to the value of the natural environment and our built heritage, and with it really became the first of the government legislation and government bodies to look after our heritage. Before the 70s, we didn't have any of those things embedded in legislation or government. So this book was done by some mates of ours, in fact, Tina's boss, Peter Lovell, and it was an initiative of the Australian Council of National Trusts and the Historic Buildings Preservation Council, founded in 1974, which is now the Historic Buildings Council. And it promoted more than 60 demonstration case studies of projects across many building types of the way of recycling buildings. I think a lot of you will remember the 60s, 70s and 80s were very bad for heritage. People were just knocking down buildings because they didn't know what to do with them. I mean, we just look back at that now and think how ignorant that was. But there was a big movement to try and make sure that people understood the value of recycling buildings, and it was a battle, and I think we've done well. I think the other thing here is there's a general misunderstanding that older buildings are not resilient enough to survive the demands of climate change. And this is demonstrably not true. Older buildings are inherently sustainable, albeit with various complications. And there are three important factors, I think, in maintaining climate resilience in older buildings. Firstly, the first thing is to retain them, adapt them, and update their energy efficiencies, because that's the sort of major area where they fall short. Secondly, that they are occupied and actively used. Vacant buildings lead to rapid decline, and really it's the worst thing that can happen to a heritage building. And thirdly, that you undertake timely and proactive maintenance. So the idea you keep the building, you adapt it, you occupy it, you upgrade it, and you look after it. I mean, makes sense. So I think the next thing to sort of consider here is how to adapt buildings to climate change. And there are now many established procedures. Most important task, I think, put simply, is thermal performance, which is basically wall, roof and window areas in a building. And we have new technologies and energy efficiency understandings now, and effectively these are legislated in practice. So building permits now require these things. And this is an example here at South Melbourne Town Hall, where a building's being adapted, upgraded, double glazing, improved insulation in the roof, a number of factors which bring the building up to modern standards, and yet you keep the heritage values of the building. The next thing which I think we've struggled with as a practice over the years is improving the performance of windows. So the windows are usually the weak link in any building. That's where the energy leaks and you find overheating. And the complication here with the window types, which are typically in our 19th century buildings, are double hung sash windows, which are counterbalanced. So to change the glass, which is usually 3 or 4 millimetres thick, the window sash is not big enough to take a double glazed unit. So you either have to rebuild the sash and replace it, which always isn't a good outcome, or you can use solar glass, or you can do what we call jockey sashes, where you in fact add a second sash so that you keep the heritage window, but you're able to improve the solar performance of the window. The next thing, this is a little subject that annoys the hell out of me, is the limitations on solar panels. And I suspect a lot of you may have had problems in this area where a lot of heritage overlays don't allow the installation of solar panels seen from the street. This is a really good example of a really neat job on a little cottage, including a battery installation. And this is the future. I mean, basically, the biggest change to reducing energy consumption in buildings is solar installations with batteries. You can almost get to no power grid requirements. So I just think this is an area that needs to be challenged a bit harder, and I think if it's done well, we shouldn't have so much restrictions on solar panels. I'll move on a bit more quickly here. Adaptive reuse. This is probably the biggest single thing that saved our heritage buildings. And I think the observation is that older buildings are amazingly resilient and they can tolerate a number of adaptations over their lifetime. In fact, we've renovated buildings 2 or 3 times and different uses sometimes. And I think these are the 6 standard architectural strategies which we use in the idea of adaptive reuse. And the first one is that you just leave the minimum. The building is good, it's been lovingly looked after, and it's still fit for purpose. The second thing is restoring, and this is where there's a sufficient original fabric that it can be maintained and restored. The third one is called editing, where you strip out later unsympathetic changes to reveal the core fabric of the original building, and then you do your work. The fourth one is called adding, and here contemporary additions are added to accommodate new uses and services that otherwise don't fit in the original building. It's quite a good strategy because you leave the heritage building alone, and those things like lifts and plant rooms and other things that don't fit in a heritage building, you do in an extension. Adapt is another one where it's a change of use or a reimagined original use. So some buildings adapt to this much more readily than others, like some of the industrial buildings. And then there's the idea of new buildings added as companion buildings, separated but connected to the original building. And then separate to adaptive reuse is another thing we call continuity of use. And this is where a building's original use can be maintained but brought up to contemporary standards. This is one of my first jobs as a young architect. And it's a little sort of ruinous bluestone building in a paddock down near Geelong, and it was lovingly turned back into a beautiful little house. And I think it just shows when, in this case, the people who owned the house, they just thought this would be a wonderful project. And I think a lot of people these days realise the value of older buildings and the kind of character that you get. And so this is a really good outcome. Last things in adaptive reuse. I won't go through these now. I think we've talked enough. Yeah. Unless you want me to go on. Probably just this last slide. This is the South Melbourne Town Hall project we're working on at the moment. And what's incredible about it is it's one of the first civic buildings that had a multitude of uses built into the original building. So it's got the council chambers, the main civic hall, had a little post office, a courthouse, police cells, a little fire station, and a mechanics institute, all built in the one building. And so this idea that buildings can tolerate many uses, more of a mixed use idea, and that be adapted and add to the richness of the building, I think is what's really interesting about the state of architectural practice today. So thank you.
Thank you, Peter. Tina, would you like to come up?
Good morning. Today I wanted to talk more about embodied energy and the reuse of existing buildings as a really important solution to climate change. Embodied energy is the total amount of energy consumed through a building's life cycle. So it includes its raw material extraction, manufacturing, transport, the operation of the building, and its disposal. It is increasingly becoming a key consideration when we discuss sustainability. But the issue is that it is abstract for most of us, and the information that we have to work with, such as the information I have on this slide, doesn't make it easy to understand and compare materials. And so what we're finding is that a lot of well-marketed new materials, such as ones which sequester carbon or say that they're 100% offset, are skewing, I think, the general public's understanding of what the impact of a building really is. In Australia, there's limited incentive to retain and reuse buildings. In fact, like this Volume Builders ad, it is the opposite. There's also the stigma of the burden of working with existing buildings. And we've got a pretty hot construction market, so builders have the ability to choose what sort of projects they want to work on or what sort of services they offer as a firm. And then there's also issues with feasibility, like how can it be done when apartments are strata titled, or how can you do it to avoid disturbance to people as much as possible? What this means is that Australia is falling behind compared to other countries. This is just one of many studies of G20 countries, but it shows that we are behind countries like Germany and the Netherlands and the UK in terms of what improvements we're achieving with retrofits and also what policies we have in place to actually incentivise change. Where do I aim the clicker? Oh, okay, all right. This example in London is really interesting. It's quite a high-profile case about the Marks and Spencer building. And originally the developer had a business as usual proposal to demolish the building and build a new one. But this was then overturned by the government and then eventually appealed in court because it was seen as not aligning with the retrofit policy that the City of Westminster had in place. And while it wasn't a happy ending and they ended up demolishing the building anyway, I think it's a really important example, and I think it is showing that things are changing. So I wanted to talk through 4 case studies of how retrofits can be adapted to different contexts while still being harmonious with the architecture, being feasible and being sustainable. So the first one is the Philip Smith Centre. This is the project we just finished in Hobart. It was built as a teaching facility and our work was really to refurbish it to continue its use as such. So when we started on the project, a lot of the features of the spaces that you can see in these historical photos were still intact. So what that meant was that we had to take a really light touch approach to try and keep all of this intact. So our strategy was to insulate the roof, draft-proof the windows, and also be very strategic with where we were installing mechanical ventilation, heating, and cooling. This is a photo of the space before we did our work, and a photo of the space after. So you can see limited change. Outside, we restored the facades and used the historical drawing that you can see on the bottom right as a reference. And we also infilled the verandas with some guillotine windows just so we could maximize the use of this building, and it now provides some really nice breakout spaces for students. The really important thing that we learnt from this project is just how all of this work stacks up in terms of numbers. So we did 2 scenarios and calculated what the upfront carbon was in each instance. So the first one is where we just compared new materials, so business as usual standard materials versus what we proposed, which we had responsibly selected materials with renewable content that were biodegradable and had a high recycled content. And the result was that we achieved about a 20% reduction, so about 50 kilograms of carbon dioxide equivalent. But then we did a scenario whereby, in theory, if we were to reconstruct the entire building using modern construction methods, and we compared that with the interventions that we did, the result was that it was like over 75% difference and over 500 kilograms of carbon dioxide difference. So you can see this is really where the difference is and where the impact is. At the other end of the scale in terms of level of intervention, this is Old Quad at the University of Melbourne. It's the first state-listed heritage building where we applied a passive house retrofit strategy. In this instance, the interior had been altered quite a lot, and so we had the flexibility to be a bit more wholesale in our strategy. So we created a new high-performance building envelope within the existing building. And these are some of the construction photos. You can see it consisted of structural insulated panels, a second set of windows inside, air tightness membranes, and a ventilation gap between the new envelope and the existing facade so that we could still let the building breathe. And this is the finished interior. And the last two projects are really just about the fact that just because there's no legislation or there's no heritage policy protecting a building, it doesn't mean that we can't just take the initiative and just do it anyway. So this is a house that Lovell Chen did about 30 years ago, and the second generation of clients came back to us and asked us to upgrade the building performance and then also reconfigure the inside so it would suit their ways of living. So it's a story of family heritage, really. And the last example is the amenities block at the Tower Hill Wildlife Reserve, which sits next to the very iconic Robin Boyd designed visitor centre with the roof that looks like a volcanic landscape. In this instance, the building was originally slated for demolition. It was going to be replaced with some standard toilet blocks, and we advocated for its retention based on a series of values, but embodied energy was one of the values that we pushed and were able to achieve a very positive outcome. So just in summary, there are different approaches that we can apply for different contexts. Retaining an existing building has the most impact, and I think the most important decision that we can make is to value the embodied energy of a building as much, if not equally, with its heritage values. Thank you.
Thanks, Tina. It's great to see some really practical examples of everything that we're talking about. Were there any burning questions from the floor before we got our panel kind of started? Because I've got a couple. Maybe I'll get. Oh, yeah.
I was just curious about whether the technology is changing with respect to solar panels to make them more compatible with the appearance of the room.
Yes, in a big way. I think the technology behind solar panels, and I just did this little exercise last week on a project where the roof is sloping southwards, and yet when we looked up the current flat panel design, it's still got 80% efficiency. And so we'll go ahead with it. But, years ago you couldn't possibly think of putting solar panels on a south-facing sloping roof. And then there are all sorts of integrated things now where the roofing is the solar panel. It's not separate. It's not separately installed. And then there's even fancy paints. They reckon cars one day will run just by the fancy paint. So no, the technologies are exciting, and it takes a while. The building industry is a very slow-moving beast, and it takes quite a long time to get these new technologies affordable. So they're there, and it just, once people start using them, then they become more accepted. As you know, solar panels now, piece of cake, everyone has them. So no, it's very exciting.
And did you find, Peter, that those products are available in the Australian or Victorian market?
Yeah, sure. Like we have this huge problem where we probably half invented these ideas, but they get built elsewhere. That's kind of the nature of the world we live in. But that's changing. But no, this is now commonplace. In fact, one of the bigger problems is older solar panels. They're very hard to recycle, and the panels do deteriorate with age. And if you don't clean them and so on, then their efficiencies do go down. So I guess these are just the constant things that we have to be aware of in the building industry.
Yeah.
But no, they're available.
Yeah, great. Thank you. Great.
Well, people think it's an aesthetic thing, that it upsets the look of the building. And I think a little bit like, well, it's a bolt-on, bolt-off thing. So it's not really affecting the fabric of the building. That's the first most important thing. And then, I mean, you do see around some very clumsy installations, people sort of hunting for the right angle. Like originally, the only efficient way you could install a solar panel was at our latitude, which was, like whatever it is, 27 degrees, I think, was it? And it had to face essentially north. But now that you can get these flat panels that can sit on almost any slope of the roof, and it's a bit harder when you've got gabled roofs that have funny shapes because the panels are only made rectangular. So there are issues still to deal with, but I personally feel we should have it's not that important to me. I think solar panels are what they are. People understand them, and I think we can tolerate more of them rather than less. I don't know how others feel.
Yeah.
No, I would agree. I think there's one of the things when assessing as a heritage advisor is the impact on the streetscape, but also about identifying that a change is discernible as a new change. And it's very clear that a solar panel is not part of the old building. So, and also, yeah, they're completely removable, and yeah, the technologies are changing. And
Sorry,
yeah.
Is that the same for like a slate roof? That obviously a metal roof is a bit easier to replace. Is the impact of a solar panel on a slate roof just as low, or is it a higher
No,
impact?
so there's a different issue with slate roofs that they can't take the stresses of the installation.
Yeah,
So we actually did we had a Como assessed, which has a slate roof, our Como mansion, and there wasn't anywhere on that roof that wouldn't do damage, or we'd have to remove the slates to install it. So that's another issue. But we've got buildings with corrugated iron roofs, so there's options available, and we just need to explore options, which is how we provide solutions to these heritage challenges sometimes.
I agree on the slate roof thing. We've never managed to get one installed on a slate roof. They're just too fragile. And not only that, with safe roof access, as you know, we're responsible now that we have to have ways that people can get onto the roof safely. And it's almost impossible with a slate roof to do that. And it can usually only be done off a cherry picker. So usually with lots of heritage buildings, they very smartly put all the slate on the outside of the roofs, and all the inner valleys are all corrugated iron.
Yeah.
Yeah.
So there's nearly always somewhere where you can put it, but it is like very, very difficult on a slate roof.
And outbuildings, there's often great outbuilding with corrugated
Yeah, it's always
iron
important to look at what other buildings there are on the site that might be able to accommodate the solar panels before necessarily putting them on the front street-facing roof.
And some of those integrated systems that Peter mentioned before, where you've got the solar panel that almost looks like a tile, we've been able to use those like really successfully with buildings with slate roofs. So whether it's
That's
like
a really
an
exciting
extension
development
next
in
to
the
it.
technology, isn't it? Yeah.
So it actually works quite well with a slate roof.
And so great that it's available on the Australian market now. Yeah. Great question, thank you. Good. Yes. Sorry, I might just repeat the question for everyone. There was a cool tool that Sam had in her presentation for cleaning gutters, and there's a question as to whether there's a tool for cleaning solar panels, because that's obviously going to be a maintenance issue for people. I mean, how hard is it to maintain your solar panels?
Oh, no, it's tricky. And often solar panels are you need a tradesperson to be able to do it probably. I don't think it's something you should be tackling yourself. I mean, like ladders, roofs, man, just got to stay away from all that. So I think it's just every so often, maybe every 5 years or something, you get someone to professionally clean it. But no, I wouldn't be doing it yourself.
But also the gutter vacs are new technology that, it's more readily available, so we don't have to use ladders to clean our gutters, because it's so important to clean gutters, and access is such an issue. Who knows? Is there an entrepreneur out there that can provide a tool?
Leaf blower, very successfully.
I'm sure there won't be one on the market soon.
Got any other questions? Yeah, down here. Yeah. So the question was, why aren't we using lime anymore?
Yeah.
Sam talked about all the amazing benefits of
It's
lime.
engineering, building, and structural people. Like, I completely agree with what Sam's saying. I mean, I think the lime mortars, the lime renders, they're all much more tolerant to building performance over the years. Now that we've got, the South Melbourne Town Hall is a good example where they do a structural test on the strength of the mortar, and because the building's 140 years old, it does lose its strength, and so the bond between the brick and the mortar, so long as you don't touch it or it's not under stress, then it won't pass anything like the kind of structural grades that are needed. And now we have a huge complication with seismic performance in heritage buildings, and this is very impactful because top-heavy, load-bearing buildings do not perform well in seismic situations, and so we're finding a lot of additional structural strengthening is not welcome, but it's kind of the future. We have to deal with seismic strengthening, and the mortars just aren't strong enough. So I mean, in some cases, the new mortars are stronger than the brick. You try and get the mortar off a brick and you'll break the brick before you break the mortar, which is crazy. I mean, we just don't need mortar that strong, but the regulations are really strict on this and it's a frustration.
Yeah, so it's, as well as what Peter said, it's also building code. It doesn't stop us using lime in other like finishes and things like that, and renders. There's loss of skills. They're not training people to use lime. Cement is, everybody just goes to that because it's quicker, but it's not actually more sustainable. Many issues around why we're not using lime, but we could definitely be using it. But your tradespeople, your brickies, wouldn't know how to use lime these days. Yeah.
Yeah, trying to source the traditional tradespeople who know how to use these materials is harder.
Just going on from what the gentleman was saying, is there a possibility, I hear about when you're talking about the mortar, having a clear, either matte or gloss, but heritage, at least you have the benefit of the visual presence of what it is, instead of either maybe like what my dad has done in the past, like many years ago, and painted it white so that the mortar doesn't get out, but to enhance at least a compromise between old traditions and new innovations. Is there something like that that could be done?
No. Probably no. And the reason is, as what Sam was describing before, you probably missed this, is that this system allows the brickwork to breathe and therefore it will evaporate moisture, whereas as soon as you seal, and modern paints are like this unless you lose breathable paints, then what you're doing is trapping the moisture in the brickwork and the mortar joints, and that's when it deteriorates.
But then couldn't you have, within stages, breathing hubs?
I'm not aware of this. Maybe some other more...
It's like a damp course, you know,
Yeah.
a damp course, and then you have spacing, so therefore it can be breathing, or
Yeah.
or can a brick
Well, it'll
breathe
depend.
on one side but not the other?
Well, it depends whether it's got a lot of the older buildings don't have a cavity at all. They're just solid brickwork, and therefore that's more complicated. When you've got a cavity, which is really what, post 1900 or whatever, pretty much,
Yep.
then the cavity allows the outer face to breathe. But normally with an older building that doesn't have cavities, it's a problem. I mean, you really just can't provide enough ventilation.
Even on a part, even on a part of the building, you need the whole building to perform. It's been designed in a way that it's a whole. It's like a human. It's a breathing thing, and if you treat it like that, if you think of it in that sort of system, yes, or you don't wear polyester on a yes.
It's probably more about the maintenance. Like, mortar will inevitably fall out, but there's a process where every, say, 30 years we will repoint buildings, and that's to make sure that any gaps that are there from water being fallen out is filled, so that you don't get water collecting. So that's, I think, that understanding and the need to do that would need to be built into it, but that's probably the best way of maintaining the building long term.
Thank you, great question.
Well, we had lots of good questions.
Yeah.
I just want to make one comment. I'm really pleased to see what you've done with the toilets at the town.
Thank you.
I thought they would just get, the prefab horrible thing stuck in the corner. And it's just terrific to see that.
Thank you. It was a lot of work, and because we didn't really respond to what the brief asked us initially. There was a lot of bureaucratic obstacles that we had to get through, but it was a really good outcome in the end. And in that instance, when we did the project, we learnt a lot about the amenities block, and the more we learnt about it, the more we realised that it was actually quite a significant building in itself. Because for those who might be familiar with the site, there's the visitor centre is this really pure circular building, and at a point after Robin Boyd designed it, they realised that they needed toilets and offices and storage, and they were, I don't know, And then they were actually going to section off a wedge of this beautiful circular building to put that program in. And then at some point, the Public Works Department and the local regeneration advocates, they said, no, we can't do that. Let's build an extra building. And so that's what they built. And it was this process of research and discovery where we realized this really important role that it had. And it was also, we needed more space, and if we demolished it, we would have only been able to fund new toilets. So there were just lots of reasons that helped us retain it. And yeah, we're really pleased that it's something that we didn't have to do, but we did. Yeah. Thank you.
Whilst we've got you there, Tina, I was wondering, when people, say someone's got a heritage place, whether it's a domestic dwelling or a larger building, and they want to start retrofitting it and improving the energy performance of their building, where would they start on that process?
I think the good news is that a lot of the buildings, like from the Victorian era all the way to the pre-war era, the construction is quite similar, and you can gain a lot just by insulating the roof and draft-proofing the windows. There are some pretty big gains that can be had with fairly simple works, and that people can just go ahead and do that. So I think the thing that we're conscious of as building professionals is that the process of building is getting more and more complicated, and a lot of the time you've got to involve architects and engineers and things like that when it gets more complicated. But there are, insulating the roof, insulating your floor and insulating your walls if you can, and draft-proofing your windows is a really easy way to get very good improvements. Yeah. I was also going to say there are also rebates that are available. So there are good rebates at the moment for changing out gas appliances with electrical. And from what I know, there's also some rebates coming for insulation of buildings as well. So it's good to look out for those to help you.
And electrifying seems to be a big way that you can really reduce the carbon footprint of your building. And that doesn't often have a huge impact on the heritage.
Yeah, that is quite simple. Yeah, and the solar rebates that we have in Australia have been really successful. I think when I was doing some research for our presentation, I think we're actually being described as best practice in terms of our rollout of solar panels in domestic applications. So it really has been very successful, and I think there are ways that we can learn from that, how we actually rolled that out in terms of doing other parts of the retrofit to buildings.
And Sam, do you know where people can find resources to assist with this type of work?
Well, I know that the Heritage Council has a number of resources.
So the Heritage Council have published, a little plug, the Heritage Council have actually published some guidelines on, I guess, the impact of climate change on heritage places and things to look out for, which is a good resource.
Also really easy ways to help provide thermal performance in heritage buildings. Yep. And the National Trust also has resources.
There's a lot on the web.
Yeah, there's a lot.
Just Google anything you like.
Yep.
Really interesting information will come up, either projects or guidelines or whatever else. So that's the great thing about the internet. Good information.
Yes, and just another from heritage building perspective, the Society for the Protection of Ancient Buildings produces a lot of really great technical bulletins on all of these sorts of things, maintenance and how to look after heritage buildings, but also how to make them more resilient to climate change, more sustainable, all those sorts of things.
Yeah. Thank you.
What a bad story.
I found that really interesting, the point you made about embodied carbon. I work in the construction industry and big construction projects, and I found it really frustrating as an enviro to quantify, whether a material is actually sustainable or not. And now working for a construction company and stuff, and we're looking at trying to make business cases
Yeah.
Yeah.
kind of leverage value of the alternative.
Yeah.
So I guess to summarise that, how easy or hard is it to undertake an embodied energy analysis or a life cycle assessment analysis? Yeah, and how do people get that done?
There are consultants now, like we have to use consultants. It's too technical, and there are all these kind of procedures that are set up, like they're kind of worldwide standards that are applied. And the two big ones in construction are concrete and steel. Like, it is almost impossible to see how we can get green concrete and green steel. So lots of other things are easier, like there's a huge movement towards timber in construction. That has great benefit, both in recycling and in less embodied carbon. The other thing we've found is, so you really need to find consultants, and they're not necessarily that expensive. They can do the audit, and they can tell you, like with charts and so on, where the problems are and what you need to try and address. Yeah.
To consider like a library of materials.
Yeah. Yeah. Yeah.
Yeah, but
There is
also I think Tina can talk to this, but I think it's just amazing that Level 10 are providing that comparative data. I think that's what we need. We need that base data to say, if we demolish this building, what would we have lost, as opposed to how much. Cost also of retrofitting compared with demolishing and rebuilding. We need that data. We need that base data to start demonstrating that it's a real thing. And the work that Level 10 are doing, that's amazing.
Thank you.
Really exciting thing for me, because if you can actually get a number and
you can.
convince the engineers that it's a business case.
Exactly. But also the developers, like cost is what's driving all of this.
Yeah, in the example I showed, we had a ESD consultant work with us, and we used the Green Star calculator. So that's quite I think you just need to subscribe to that and you get access to it. The way it works is that it's got like a library of standard materials and what the carbon impact is of all those materials. But then when we select something, so we might find, like, so for that project, we selected a carpet which was made out of goat's hair, so like largely renewable. They then have EPDs, which are called environmental product declarations, and it lists out the entire manufacturing process, what happens, and all this data, which then gets plugged into this calculator. So you can then find out what the actual impact is at the end. But it is, the way it's set up, it's very difficult for you to compare it until you've actually put it into the calculator, and that's an issue. And the other thing is that because we do rely on ESD consultants, it can make the process a little bit stagnated, in that you have to try and make all the decisions and then get it calculated. So it's not as fluid as we would like it to be. So we've tested some software like in-house that just uses standard materials, but it just gives us a little bit of control to manipulate it. And it's mainly just to see it, like volumetrics more so, like if we actually made this building smaller or we change this from concrete to timber, what the impact might be. So it gets us like pretty, like most of the way, but when it comes to actually presenting the data, it does, we do need ESD consultants to help. We do, yeah.
And if anyone wants to do a research project, I think an interesting thing about that is like the data that you put in is really important. And like Sam was saying, a lot of the materials used for historic buildings were actually locally sourced. So you'd be really wonderful to have that data of like, okay, well, actually, if we're getting ironbark, grown locally in Victoria as opposed to the standard numbers that are in the software, you might get even better results. Okay, I am conscious of time. We should wrap up soon, but we've got maybe one more question over here.
Going back to the software, wouldn't it be better also to have open source calculators so that, then collectively you're getting a hell of a lot more data?
Yes, that's a very good point. There is one open source database. It's called the EPIC database, and that has all the standard materials and what the impacts are. The tricky thing is that with calculating embodied carbon, You've also got to look at the transport. So if I use it in Melbourne or versus in Brisbane, you've got to then apply like a transport.
Levy.
Yeah, you have to then go and take that and calculate that. So it's a bit hard to compare it like for like.
A very good general understanding.
Yeah, you get a good general.
Try and avoid and which ones have got better.
Yes. Yes.
And we're never going to get it
No, we're never gonna
absolutely perfect and right, but yeah, it gives a very good indicator. Yeah.
Take from A to B
And you can
sometimes.
see like the
Yeah,
graph
good
that you
for
showed.
comparisons. Yeah.
Yeah, big differences. Okay. Well, thank you so much, everybody. That was a really great conversation, and I've still got a lot of questions, but that's okay. We'll let everyone get on with their day and enjoy this festival. Thanks, everybody, for coming.